All right, midterm practice problem number 3. Consider a DT system with input signal x of n and corresponding output signal y of n equal to x minus n plus 3, and determining whether the system has memory, is time invariant, linear, causal, stable, and we have to justify the answer in each case. So we can start with memory. Let's just let n be greater than 0. Then negative n will be less than n, and hence y of n, and remember we said this n is greater than 0, equals x negative n plus 3. So if this is greater than 0 right here, then this is going to be a negative n, and it's going to be in the past, and therefore requires memory. Or, in other words, not mem or less. All right, now B, time invariance. This one's a little trickier. It's slightly trickier. So let's if we start with one input, let's let x1 of n equal x of n. Then we have that y1 of n is equal to x1 negative n plus 3. And if we have a time shift, if we have a shifted, if we have x2 of n, and that's equal to some time shifted version of x1 of n, and we plug x2 into our formula, we get y2 of n is equal to x2 of negative n plus 3. And if we swap this out, if we swap x2 of n out with this right here, then we get y2 of n is equal to x1 of negative n minus n sub naught. So we're just shifting it, right? And if a time invariant system means that, well, if we shift the input, then the output's going to shift with it. So we'll come down here, we'll see that if we shift y1 by some n naught, and we use our formula for x1 for our formula for y1 right here, then we get that y1 of n minus n naught is equal to x1 minus, and here's our shift now, n sub naught plus 3, which we expand that, we get, and that's equal to x1 minus n plus n sub naught plus 3, and this does not equal what we found right here. It does not equal y2 of n. So system is not time invariant. All right, C, linearity. let's have two signals. Three signal. Let's let x3 be a linear combination of x1 and x2. So we get ax1 plus bx2 of n. And if the transform, so here's our sum right here. Now, if t represents the transform, so if we go from x of n to y of n, t is going to represent what transforms us from x of n to y of n. So if the system's linear, then t of x1, or t of the linear combination, or ax1 of n, plus t, the transform of bx2 of n, should equal the transform of x3 of n. And because this is linear, if it's going to be linear, we can take these constants out, put them up front, so we'll have a t x1 of n plus b t x2 of n, and that equals t x3 of n. And now we're going to apply our transform by swapping out x of n right here for what we get on this side. So then we'll have a, and we have x1 minus n plus 3 plus b x2 negative n plus 3 equal to x3 negative n plus 3, which is going to be equal to, let's make a line here so we kind of see, we get ax1 negative n plus a times 3 plus bx2 negative n plus b times 3, and that's equal to x3 negative n plus 3. So here's what we have so far, right? Well, let's take this part right here, and let's take a closer look at this. So x3 of negative n plus 3 is equal to, well, here's our relationship for x3 up top here. Then we get a x1 negative n plus b x2 negative n plus 3, and we can just drop the brackets. X3 negative n plus 3 is equal to ax1 negative n plus bx2 negative n plus 3. And we can see that, you know, right here we have this 3b, or 3a, and right here we have this 3b, and down here we only have this 3. So this relationship is not satisfied, and therefore system is not linear. All right, so let's see if we can get some room over here for D, which is causality. And we're going to do this kind of like we did the memory one. We're going to say, all right, well, let's let n, then instead of saying greater than, so let's say, let's let n be less than 0, right? If n's less than 0, if n is less than 0, then y, and we just pick some negative number, we'll say y1 is equal to x evaluated at a negative 1 plus 3, which is equal to x evaluated at 1 plus 3. And you know, we have an n in the negative that depends on the n in the future. Well, that means the system's not causal, so it's not causal. Now for stability, stability is a fairly simple one. Y of n equals x of negative n plus 3. Well, if we have a bounded input and we get a bounded output, BIBO, that defines our stability, right? So if the magnitude of our input is less than some limit b, right? Then we get that x negative n plus 3 is going to be less than b plus 3. And this is essentially equal to y. So we get y n is going to be less than b plus 3. And therefore, we put a bounded input in. It's less than the bound, and we get a bounded output. So therefore, the system is stable. Oh man, can't spell.